So it was brought to my attention there's no proof of integration by parts. So I usually do these in lectures and don't have you take notes on it, but we don't have lectures together like that. So here we go. So in the black here, you see product rule, right? The derivative of fg is first d second plus second d first, right? Okay, so then I went in and took the red integral of both sides. So the red integral on this side here, so the integral, right, the integral and the derivative, they cancel each other out, so you just get f times g. All right, this one here I just broke up into two integrals around the addition sign, right? So here's fg prime, and there's gf prime, and they're both in their own separate integrals. Okay, I'm going to solve for this one, so this is it here. And so then I'm going to move this to the other side, so I get fg minus this integral, right? Looking a little familiar? Okay, so this is our original problem. So this is where the u equaling f of x comes from, and this is where the dv equaling the g prime of x comes from. So if I take the antiderivative here, I get g, and if I take the derivative here, I get f prime of x dx. So here it is. Put it in color here. So here I have u times v, right, minus the integral of v, right, that's v, and then times du. So there's the integration by parts proof. So integration by parts is really undoing product rule. Okay, so then another comment that I would make in class that I don't believe I made specifically in any notes is integrals are hard. Okay, keep that in mind. Integrals are hard. To take a derivative is easy, but when you're taking an integral, you're undoing a derivative. That's challenging. So keep that in mind as you're going through, and I purposely put 20 problems on almost every homework. Okay, so we're going to be working the problems in our groups, so we'll be able to figure out all the mistakes, but I want you to use and build your discernment. So look at a problem and decide, what kind of problem is this? Is this an easy U? Is this a type 1? Is this a type 2? And as we move forward, I'm going to be rotating in old problems. So make sure that after you finish the problems, and making sure you can crank through all the details of it, I'd encourage you to look over them again and look at number 1 and say, could I decide, would I be able to discern that this is integration by parts type 2? Could I recognize that now? So it's almost like you want to memorize the types of problems that need the different techniques, because we're going to learn about 6 techniques, and the techniques you want to think of as tools. And so a integral that needs the tool of integration by parts cannot be used with trig substitution, which we'll learn in 7.3 in the section 3. So you want to make sure that you're understanding, oh right, this is that type of problem, because as the problems, as we learn the techniques, and as you look at the wide array of problems, the challenge is going to be, what technique do I use? So make sure you're investing time after you finish working the problems to look back at them again. And our problems are going to get long, and so that's why I'm putting the easy use substitutions in there, because that's so often our second or third step after we do use a new tool. So keep this in mind. Integrals are hard, so that you spend a significant amount of time studying, especially in the beginning as you're learning how to recognize what tool to use when.